Hello, Algebra 2 class. This is Mr. AC. I want to go over a tutorial video on how we can solve problems like this right here, which require two formulas that we talked about in class. So the problem that I have listed is 8 raised to the n plus 2 equals 21. Now, this could be a good time right now to, before I even go over this problem, I want to tell you some of the things I've written down. So as you can see here, we have the logarithmic definition, which says that our base b raised to the x equals a. It's the same thing as log base b of a equals x. Okay, so if you look here, our input becomes our output. Our input becomes our output. And our output becomes our input. So remember that logarithms and exponentials are inverses of each other, which is why we're able to do that. We also have another formula written down here, which says that log base of b of a equals log of a divided by log of b. I wasn't able to put it all right here because I ran out of room. Now remember that this is called the change of base formula. Change of base. Now before we get started, this might be a good idea now for you to just write this information down and then pause it, and then we're going to go ahead and then get back to the video. So pause it. Okay, hopefully now you have written it down. So let us begin dissecting this problem. I also put this PEMDAS chart because I realized that for some of you this is the way you learned it and it helps you learn. So I did want to put it down. Whenever we're solving for our variable, a variable like in this case, we always try to undo everything, right? We're always trying to undo it. So we always want to undo any addition or subtracting first, multiplying, dividing, then move our way up and stuff. So I look at my problem and I recognize right away that I want to undo this subtracting sign. I want to undo this addition sign. So the opposite of addition is, I'll let you finish it. The opposite of addition is, that's correct, you got it right, that's subtracting. So the first thing I want to do is just subtract 2 to both sides. Okay. So we're left with a to the n. 2 minus 2, that cancels each other out. Okay, now we have 21 minus 2. Well, we know that 21 minus 2, well, that's just 19. Now, another reason why I subtracted 2 to both sides first over anything else is that I want this formula I have written down, this right here, or this formula right here, to look almost identical to this up here. When I subtract 2 to both sides, I get that, right? So our base b in this case is 8, so I'm just going to label that, that's b. Our input x, in this case our input is n, so I'll label that. And then a out here, the output in our problem, well, a is 19. Okay, so we know what our base is, 8, we know what our input, it's n, and we know our output, which is 19. I know all the information now to write this as a logarithmic expression. So what I want to do is write down below, I'll go ahead and write down log, okay, this is our base, well, our base is 8, okay. Now remember, our output becomes our input, so when we look at this value a, well, we labeled our a, our output is 19, so our output is 19, so that will become our input. Okay, and then our input n, our input up here, becomes our output, Cool. So I'm almost done now. I finally have used the logarithmic definition to go from exponential to logarithm. Now this is where you want to use the change of base formula. You're going to write down n equals, and now you see here log over base b of a equals log of a divided by log of b. So just following this formula, we can rewrite this. We know our base is 8, and we know our a value, our input, is 19. So we can do log of 19 divided by log of 8. Now, maybe rewrite that one more time because that maybe you can't really see that. Log of 19. There we go. Now we can use our calculator to enter that in and find out what our n value is. Unfortunately, I do not have my calculator with me, so I'm going to finish this and just leave it like that. But you can go ahead and do it and then find out what that value is. Perfect. Now you might be asking yourself, okay, Mr. AC, well, okay, I kind of understand how to do this and go from exponential to logarithm, but how do I go from logarithm to exponential? Okay, well, you know what? Let me go ahead and do another problem for you so you can get that down. So I'm going to erase this. Luckily, you're able to rewind to try to make sense of what I was doing, and hopefully all of that made sense. And now let us go ahead and do a problem that it's going to involve. Yep, you're right. Same thing, just going from logarithm to exponential. So let's write a problem like 3 plus log base 4 of x equals 8. All right. Now, just like before, we always want to go up this pendulum's chart. Or as you can see, in order for us to use this property, we need our log of our base of a to be by itself. There should be nothing there. Well, we can see in this problem, we have our log of our base 4 of x, but the thing is that we have this plus 3. So we want to undo that. We want to subtract 3 to both sides. And when we do that, we get 3 minus 3. Well, that's just 0. So what we're left with on the left-hand side is log of our base 4 of x equals, now we have 8 minus 3. Well, 8 minus 3 is 8, 7, 6, 5. So 8 minus 3 is 5. Now, we have something that looks fairly like this. We have log base of b of a equals x. Well, in our problem, we have log of base 4 of x equals 5. Okay, so like before now, I want to I'm using this and turning it into exponential. So I'm taking this expression here and I'm going to turn it into an exponential because I'm trying to isolate x. And this is one of the strategies that I have available. So in order to do that, okay, we notice that this is our base. Oh, let me go ahead and use a different color. This is our base. Cool. This is our input, A. I'm just labeling it just like up here. The input in here is A, so our A is our X, our base is our 4, and then our X value out here, which is really our output, is 5. Okay. Now, I'm going to go ahead and use this property. So we have our base raised to the x equals a, right? Just like over here, we're using this to turn it into this. So we know, so the first thing I want to write down is 4, okay? Now this is where it could be really helpful. You can use the same strategy we used before, or you can just know the fact that because they're inverses of each other, when we have this expression, the input will become the output, and the output will become the input. So I look up here, well, this is my input, so I know for a fact that my input has to become my, you guessed correctly, that is, it will become the output. So there it goes. Input becomes our output, and then our output becomes our, oh, you are so smart, you're correct, becomes your input. Now go ahead and use your calculator to go ahead and solve that if you would like, or I'll just do it at the top of my brain, and x equals 1024. Just kidding, I didn't do it in my brain, I actually used my calculator. Okay, so this kind of sums up at least this example. Using this strategy, you're able to solve a lot of the story problems. So I'm not going to do any story problems, but look back to some of the problems that involve percentages and involve starting values and compound interest, or the ones that we did with the music video views on the starter, and see how you can use this strategy to kind of help solve those problems, because those are what give these problems, it puts it into context, and we love to see that on the exam. So make sure to study that. Thank you.